everyone. Magnetism and Matter Part 2. The Earth's magnetism, magnetization and magnetic intensity. These are the topics that will be discussed in this video. First we shall see about the Earth's magnetism. The reason why a bar magnet when suspended freely points in north-south direction is due to the Earth's giant magnetic field. The strength of the Earth's magnetic field varies from place to place on the Earth's surface, its value being of the order of 10 raised to minus 5 Tesla. Now, the magnetic field is thought to arise due to electrical currents produced by convective motion of metallic fluids, mostly consisting of molten iron and nickel in the outer core of the Earth. And this is known as the dynamo effect. Now we shall see a figure depicting Earth as a magnet. In this figure, we can see that Earth has got a magnetic dipole. The magnetic field lines of the Earth resemble that of a magnetic dipole located at the center of the Earth. The axis of the dipole does not coincide with the axis of rotation, but is presently tilted by approximately 11.3 degree. In this way of looking at it, the magnetic poles are located where the magnetic field lines due to the dipole enter or leave Earth. The location of the north magnetic pole is at a latitude of 79.74 degree north and a longitude of 71.8 degree west, a place somewhere in North Canada. The magnetic south pole is at 79.74 degrees south and 108.22 degree east in the Antarctica. The pole nearest to the geographical North Pole is called the North Magnetic Pole, while the pole close to the geographical South Pole is known as the South Magnetic Pole. Now we shall see about magnetic declination. When a magnetic needle is suspended freely in the air, it always points in the north-south direction. This direction in which a magnetic needle points freely in a particular direction free from all other attracting forces is known as magnetic meridian. Magnetic declination is defined as the angle made by the magnetic meridian with the geographical meridian. Here, geographic meridian is defined as the plane passing through the north and south poles of the Earth. It is as shown in this figure. That is, declination is the angle between the true north and the magnetic north. And it is denoted by D. The declination is greater at higher latitudes and smaller near the equator. The declination in India is small. It being 0 degree 41 minutes east at Delhi and 0 degree 58 minutes west at Mumbai. Now, another property which arises due to the Earth's magnetic field is the angle of dip or inclination. The angle made between the total of Earth's magnetic field with the surface of the Earth, which is the horizontal component of the Earth's magnetic field, is known as the angle of dip. In most of the northern hemisphere, the north pole of the dip needle tilts downwards. Likewise, in most of the southern hemisphere, the south pole of the dip needle tilts downwards. Here in this figure, we can see a point P. And in this case, BE shows the total magnetic field due to Earth. and He is the horizontal component of the magnetic field and Zd is the vertical component of the magnetic field. Here I is the angle of dip or inclination and D is the declination. Now Zd, which is the vertical component of the magnetic field, is equal to Be sin I, where I is the angle of dip. Similarly, the horizontal component He is equal to Be cos I. Therefore, tan of I, which is the tangent of angle of dip, is equal to the ratio of Zd by He. That is the ratio of vertical component of the Earth's magnetic field by the horizontal component of the Earth's magnetic field. Now we can see the concept of magnetization. A circulating electron in an atom possesses a magnetic moment. Magnetization of a sample can be defined as the net moment per unit volume. That is, capital M, which is used to denote magnetization, is equal to M net divided by V, where V is the volume. Magnetization is measured in amperes per meter. Now we can see the magnetic intensity. For that, first we can consider a solenoid. The magnetic field of this solenoid B0 is given by mu0 Ni, where I is the current flowing through the solenoid, N is the number of turns of the solenoid, and mu0 is the permeability of free space. Now, if we keep a material inside the solenoid, as shown in the second figure, the magnetic field increases and the total magnetic field B is equal to B0 plus Bm, where Bm is equal to mu0 M, where M is the magnetization of the material which is kept inside the solenoid. Therefore, we can write B is equal to B0 plus mu0 M. Now, dividing the whole equation by mu0, we get B by mu0 is equal to B0 by mu0 plus M. That is B, the total magnetic field intensity, is equal to mu0 into H plus M. Here, H is called the magnetic intensity, which is the ratio of B0 by mu0. Now, M, the magnetization, is related to the magnetic intensity as shown in this equation, that is M is equal to chi into H, where chi is called the magnetic susceptibility, which is the measure of how a magnetic material responds to an external field. Now, using these equations, we can write B, which is the magnetic field intensity, is equal to mu0 into 1 plus chi into H. Let mu r is equal to 1 plus chi. Here mu r is taken analogous to epsilon r in the case of electrostatics. Therefore, B is equal to mu0 into mu r of H or mu into H. So this is the end of this video. In this video, I have given a introduction about Earth's magnetism, the magnetic declination and the angle of dip, as well as magnetization and magnetic intensity. If you have got any doubt, please comment in the section below. Thank you.